So it is the secondary alkanol that undergoes one level of oxidation to give ketone. All right, so take note of that. Primary alkanol goes through two stages of oxidation. The first stage will yield alkanol, then complete oxidation will give you carboxylic acid or alkanoic acid. Is that okay? So for secondary, it only undergoes one stage of oxidation. Welcome to today's class. Very quickly, I'll be teaching on organic chemistry. For those of you that are writing the JUPEB exam, organic chemistry is one of the 4 aspects of chemistry that you are going to be writing in your exams. In your exams, you're going to deal with general chemistry, with physical chemistry, inorganic chemistry, and organic chemistry. So under your organic chemistry, what are the topics you can be expected? Topics like hydrocarbons, the different functional groups, and homologous series. Okay. Now, under those functional groups, there are alkanes, there are properties, chemical properties, alkanes, alkynes, alkanols, which are also the alcohols, which is what I'll be talking about today. And then you have the alkanoids, which are the esters. You have the alkanals, which are the aldehydes. Okay. You have the alkanoic acids, which are the carboxylic acids, the organic acids. You have the esters, which are the alkanoids. You have the ethers, which are alkoxy alkanes. And you have a lot of them like that. So questions can come from any of those functional groups. You are expected to know them and be able to answer questions on them. So very quickly, I'll be pointing your attention to some things you need to know about alkanols, which are the alcohols, and I'll give you some tips that you can use to answer questions on alkanols, and then you can go ahead and do well in your exams. So come with me. When we talk about alcohols, they are organic compounds that contain the hydroxyl group. And what is the hydroxyl group? The hydroxyl group is OH. Okay, so when you have OH attached to an organic compound, it is an hydroxyl compound and it is an alcohol. The next thing you need to know about alcohol is that the IUPAC name, okay, they are also called alkanols. So that is their IUPAC nomenclature. IUPAC nomenclature is alkanol. So alcohol is just like the trivia or the common name. All right, that's alcohol. So the IUPAC name is the alkanols. And then under these alkanols, we are going to be looking at the reactions they take part in. Next thing we want to talk about is the general formula for the alkanols. You remember, for every member of a homologous series. So let me quickly talk about homologous series. Homologous series, as the name implies, homologous. Homo means same. A series, if you've ever spoken about maybe your JAM series, your YX series, you see that there is not just one year in that series. There are a combination of years. All right, so that's why it's called series. So series tells you it's not just one, more than one, a lot combined. So when you say homologous series, they are members of the same family, members of the same organic family, and they have the same functional group. They belong to the same functional group. All right, and now all those members of a homologous series, they have one formula with which you can determine their individual molecular or chemical formula. That formula that all of them that you will use to derive all those members in the series, that formula is what you call the general formula. So for the alkanol, they have the general formula. So the general formula for alkanols is CnH2n plus 1 OH. CnH2n plus 1 OH. Take note of that. Now the next thing we want to talk about, we are going to be talking about the types of alcohols or the types of alkanols. The types of alkanols or the forms. Okay. Now these types, there are, or classification. Let me put it as classification. Better still, classification of alkanols. Now there are two criteria that are used to classify alkanols. So they can be classified. They can be classified using two criteria. And what are those criteria? The first one is classification based on the number of alkyl groups present. Alkyl members, number of alkyl group members present. So we are going to talk about this classification first. Classification based on the number of alkyl group members present. Under this classification, alkanols can be classified into primary alkanols, secondary alkanols, and tertiary alkanols. So the first is primary alkanol. Primary alkanol or alcohol, which you can also call 1 degree. What are primary alkanols? They have only one alkyl member attached to the alpha carbon of the chain. So what's the meaning of alpha carbon? Alpha carbon is that carbon that is carrying the functional group. So when you see the chain, so let me give you an example. If I have these, alpha carbon does not mean the carbon number 1 or this. No, alpha carbon means the carbon that is carrying the functional group. So this is an example of an organic or an alkanol. This is the functional group, the OH, but it's not on carbon 1. So carbon 1 is not the alpha carbon here. This is the alpha carbon. So how many alkyl members are connected to this alpha carbon? That is what we are talking about. So when we say primary alkanol, only one alkyl member is connected to the alpha carbon. So let's look at what that means. So if this is my alpha carbon, so I have R connected here, then here I have H and H. So this is this formula for primary alkanol. So example, let's say an example, e.g. so if I replace this R means an alkyl member. So this is the only alkyl member in this. That's why it's a primary alkanol. If I replace this with methyl, I'm going to have H, C, OH, H, then CH3. What is the name of this alkanol? Can you see this is carbon 1, 2 or 1, 2. So the functional group OH is on this, and then you have just one alkyl member, which is methyl, attached to this functional group. So this is ethanol, C2H5OH, ethanol. So this is ethanol. So an example of primary alkanol is ethanol. It's an example of primary alkanol. Now before we go to the secondary, what are the things you need to know about this primary alkanol? Number one, can you see that it has 2 hydrogen atoms that are available to take part in reaction? So, and you remember, addition of oxygen is called oxidation, and removal of hydrogen is also called oxidation. So this primary alkanol can go through 2 phases of oxidation because there are 2 hydrogen that are available to be replaced. So when this first hydrogen is removed, that is the first stage of oxidation. The complete oxidation will remove the 2 hydrogen. So primary alkanols can go through 2 stages of oxidation. The first stage it will go through will lead to formation of alkanol. Take note of that. So primary alkanol will go through the first stage, first oxidation, to give alkanol, alkanal is also called aldehyde. I was talking about primary alkanal having two available hydrogens. So these are the two available hydrogen. They are available to be replaced. The removal of hydrogen is oxidation. So they can go through two phases of oxidation. The first will remove this hydrogen. The second phase will remove this. And when the first one is removed, the product will be alkanal, which is also called aldehyde. And when there is complete, so they can add that first one is also called partial oxidation of primary alkanal. Partial oxidation will give alkanal. Primary alkanals undergo partial oxidation to give alkanal or aldehyde. You can have that. Then complete oxidation of primary alkanol yields carboxylic acid, alkanoic acid, which is also carboxylic acid. So complete oxidation of primary alkanol will yield alkanoic acid or carboxylic acid. You know, this is the OH. This is this is the alpha carbon connected to H. You have H here. You have H. You have C2H5. If I have C2H5 here, this is still a primary alkanol, but this is now 1, 2, 3. So this is propanol, or propan1-ol. They are all examples of primary alkanol. So let's go to the next one. Secondary alkanol, which is 2 degrees. What is secondary alkanols? They are alkanols that have two alkyl members attached to the alpha carbon. So the meaning of that is that two hydrogen are being replaced by alkyl members. For primary, only one hydrogen was replaced. Look at it here. There was an hydrogen here originally that was replaced. This is what I'm talking about for primary. So normally this is your OH. You have H here, you have H here, you have H here. So if I replace one hydrogen with my R, this is primary alkanol. But this time around, two hydrogen will be replaced with the alkyl members, and then only one hydrogen will be left. So for secondary alkanol, there is presence of two alkyl group members. Also, two hydrogen have been replaced with alkyl members. So here there is presence of two alkyl group members connected to the alpha carbon, joined to the alpha carbon. All right, two hydrogen have been replaced, and because of that, it can only, so secondary alkanol can only undergo one stage of oxidation. There is presence of two alkyl group members joined to the alpha carbon. Two alkyl members. So this is the meaning of that. This is the alpha carbon having the OH. So there is R, there is R. And there is only one hydrogen left. Two hydrogen have been replaced with alkyl members. These two hydrogen that were here initially have been replaced by two alkyl members. Only one hydrogen is left. So because of that, only this one hydrogen can be replaced. So it can only undergo one stage of oxidation. That means replacement of this hydrogen. And that one stage of oxidation will yield what? To yield alkanone. or ketone. Alkanone or ketone. So that is that. So let's see example of secondary alkanol. So if I represent this RR, if I represent each one with methyl, I'm going to have CH3, C, then CH3 here, okay, and then I have H here, I have OH. So look at it, this is one, this is another alkyl member, 2, 1, 2, connected to this alpha carbon, that is secondary alkanol. So how do we name this? This is carbon 1, 2, 3. So this is propan-2-ol. Propan-2-ol, that's the name. If you might be saying, how is this propan-2-ol? You can, this is a chain, you can redraw it like this, 1, 2, 3. On 2, carbon 2, that's where your OH is. Look at 1, 2 on carbon 2, your OH and H is there. Then you have CH3, CH3, CH3 here. You have CH3 here. So this is propan-2-ol. The alkanol or hydroxy group is on carbon 2. That's why it's propan-2-ol, and it's propan because 1, 2, 3, 3 carbon. So this is propan-2-ol. So if they ask you, give an example of secondary alkanol, propan-2-ol is an example of secondary alkanol. Can we give out, or can we look at another example of secondary alkanol? Let's do that now. Another example of secondary alkanol, the symbol, the formula is TrOH, then H. So another example, I can replace this with C2H5, COH, replace it with CH3 or C2H5, whatever, no matter how long the chain is, and I have H here. So how do we name these? This is 1, 2, 3, 4. That is 4 carbon. That is butan 1, 2, butan 2-ol. So this is butan 2-ol. 1, 2, 3, 4. So this is butan 2-ol. Butan 2-ol. Why is it butan 2-ol? Butane because there are 4 carbon there. 1, 2, 3, 4. Then 2-ol because the hydroxy group is on carbon number 2. This carbon 1, carbon 2. And that is why it's butan 2-ol. So let's look at tertiary. The third one is tertiary alcohol or alkanol, which is 3-degree alkanol. So the first thing you need to know in here is that there are 3 alkyl members, alkyl group members, directly connected, directly joined to the alpha carbon. How? 3 hydrogen atoms have been replaced. Now, because the 3 hydrogen atoms have been replaced, so the meaning of that is OH. So instead of having H, H, and H here, this has been replaced with alkyl member. This has been replaced. This has been replaced. So because all the 3 have been replaced now, is there any hydrogen here that is available for oxidation to be replaced? No. Therefore, tertiary, they do not undergo oxidation. They do not undergo oxidation. Why? Because there is no available hydrogen to be replaced. So example of tertiary alkanol will be what? If I replace this with CH3, then CH3, then CH3, then OH. So how do we name this? Can you try to name this? Pause the video and try to name it. Okay, you made your attempt. So let's try to name it. This is 1, 2, 3. 1, 2, 3. Count from any angle. It's 3 carbon. That's the straight chain. So it's a propan. Then the OH is on carbon 2. So it's a propan-2-ol. But there is a methyl on carbon 2. So this is 2-methyl propan-2-ol. 2-methyl propan-2-ol. This is an example of a tertiary alkanol, and it cannot go through any form of oxidation. The next thing we talk about is classification. The second criteria, classification based on Number of hydroxyl group present. So these can be classified. The first one you have monohydric, yes. Monohydric means one hydroxyl group is present. E.g. ethanol. Ethanol is C2H5OH. Then you have dihydric. Dihydric means di means two. So two hydroxyl group present. E.g. ethan 1,2-diol. So you call it a diol 1,2. So I have OH here. Then H. If I want to name this is ethane 1,2, 2 carbon ethane. So it's ethan 1,2-diol. So ethane 1,2-diol. And another name for this is glycol. That's the common name. Take note of that. Glycol. So when you hear glycol is talking about an alkanol that has two hydroxy members present. That is glycol. Let's look at the third one, which is trihydric alcohol. Now, based on the number of hydroxy group, the third one is trihydric. Trihydric alcohol. It has 3 hydroxyl present. So example is, if I have 1, 2, 3, OH, H. So this is propane because it's 3 carbon. Propane 1, 2, 3 triol. Propane 1, 2, 3 triol. Triol means 3 hydroxyl members. Propane 1, 2, 3 triol, which is also called glycerol. That's the common name or the trivial name. Glycerol. So glycerols have 3 hydroxyl members present. So that is what we'll be discussing based on the types or classification of alkanols. The next thing we talk about is the reactions that alkanols take part in. So reactions of alkanol. Reactions of alkanol. They can ask you questions on that. The first one is esterification. Esterification. So what's esterification? Esterification is the process by which esters are formed by reaction between an organic acid and an alkanol. So esterification is reaction between an organic acid and alkanol to form ester and water. Okay, so let's see. Example is, if I have ethanoic acid, this is an organic acid, plus ethanol, C2H5OH. By the time these two react together, all right, this is going to ionize here, this is going to ionize here. So if this ionizes, you have CH3COO minus, and then you have H plus here. And here you have C2H5, you have OH minus, you have plus here. So positive will join to negative. This positive will go into negative. Remember, like poles repel, unlike pole attract. So by the time this and this come together, you have CH3COO, C2H5. Then these two will form H2O. So how do we name this compound? First, what functional group does this belong to? This is an alkanoate, which is the ester. So this is named, to name alkanoate, you name this side first. So this is ethyl ethanoate, and this is water, right? So ethyl ethanoate, this is the first property that you need to know, or reaction of alkanol. Number 2 reaction of alkanol is oxidation, which we have spoken about extensively when we're talking about primary, secondary, and tertiary alkanol. So under this oxidation, primary alkanols undergo two stages of oxidation. First, to form alkanals, which is also called aldehyde, and that's partial oxidation. Then complete oxidation, to form what? Alkanoic acid. Complete oxidation to form alkanoic acid. Alkanoic acid is also called carboxylic acid. Okay, carboxylic acid, the carboxylic group, rather. Alkanoic acid, the carboxylic group. All right. So that is oxidation. Number 3, another reaction that alkanol takes part in, alkanol can undergo hydroboration or hydration, or dehydration rather. Dehydration. So if I dehydrate an alkanol, what will it give to me? So I can say dehydration of alkanol to yield alkene. So it will yield an alkene. Yes. So let me give you an example. If I have ethanol, C2H5OH, and then I dehydrate it using H2SO4, concentrated H2SO4, to dehydrate it's going to give me C2H4 plus H2O. So this C2H4 is the ethene. So if you balance this equation, carbon is 2 here, hydrogen is 5 plus 1, 6, hydrogen is 4 plus 2, 6, oxygen is 1, 1. So dehydration of alkanol will yield alkene, and an example is ethene. So these are 3 reactions. They can ask you to state any reactions. These 3, you can state them. Very easy reactions. You'll get your answer. And then let us go to the final phase of this class. Before I end this class, let's talk about preparation of alcohols. Now, when we talk about industrial preparation, alcohols are prepared majorly by fermentation of carbohydrates. So when you ferment maybe your corn, okay, or when you ferment your cassava, all right, any carbohydrate, once it goes through the process of fermentation, then you are going to have alcohols. So, but let's talk about the laboratory preparation. Now, number 1, we can prepare alcohols by hydration of alkenes. You remember I spoke about the reaction, dehydration of alkanols to give alkenes. So the reverse. One thing about organic chemistry is you can always reverse these things. Your knowledge of one, use it for the other. So when you get to properties or reactions of alkene, you can also say alkenes can be used to produce alkanols by hydration of alkene. All right. So hydration of alkene, when you hydrate alkene to yield alkanol. So example, if this is an alkene, C2H4, if I add water to it, I'm going to have C2H5OH, which is ethanol. This is 18. Number 2, acidic or alkalinic hydrolysis. So I prefer the acidic hydrolysis of esters. Esters. And what are esters? Alkanoids. Alkanoids. So this is just like the reverse of esterification. I want to reverse it now. So preparation of alcohols. Alcohols can be prepared by acidic hydrolysis of esters. All right, so let's do this. If I have my ester, CH3COO, C2H5 plus, so I want to, when we say hydrolysis, hydrolysis means you add something smaller, a smaller compound to a bigger compound to break it down. So what you are adding to this compound, it might not be water, it could be an acid, it could be a base, it could be water. All right, so I'm going to like to add water here. So if I add water here, I'm going to have CH3COOH plus C2H5OH, and then I have my this is my alcohol, ethanol, and this is my ethanoic acid. So I've been able to prepare ethanol from ester. This is ethyl ethanoate, ester, ethyl ethanoate, which is also called ester. Ethyl ethanoate ester, this is water. All right? Ethyl ethanoate. And then we've been able to prepare our alkanol. Another way we can prepare alkanols, you remember we said secondary, or we said primary alkanols can go through oxidation partially to form alkanol. So that means I can also do reduction of alkanals to give me primary alkanol. So that's the thought. Reduction of primary alkanol. Reduction of our primary alkanol. Reduction means addition of hydrogen. So if I want to do this reduction now, I can use hydrogenating compounds or reducing agents like lithium aluminum hydride. Has excess of hydrogen, it can give hydrogen. Reduction of primary alkanol. If I reduce primary alkanol, it's going to give me alkanol. Sorry, if I reduce, not reduction of primary alkanol now, I want to form primary alkanol. So I'm going to do reduction of alkanol, rather. Reduction of alkanol, yes. Reduction of alkanol to yield primary alkanol. I hope you are not confused. You remember it's the oxidation of primary alcohol that gives alkanol. So now reduction of alkanol to yield primary alcohol. No, using lithium aluminum hydride. Then I can also do reduction of alkanoic acid. Reduction of alkanoic acid, all right? Or hydrolysis of alkanoic acid. So reduction of alkanoic acid can also help to yield. So when that's complete reduction, if I do the first stage of reduction, it gives alkanol, then complete reduction will give alkanol, primary alkanol. Reduction of alkanoic acid completely to yield alkanol or alcohol. So these are laboratory processes that you can use to produce alkanols. All right. When I said acidified hydrolysis here, so it can be in the presence of maybe an acid H2SO4. All right. So, or just by adding water. By the time you add water, you break it down, and then you have that. If you check this reaction, you see that it's correct. Your C2H5, okay, then H. So let's check it. How many hydrogen do we have here? 3 plus this 8, 9, 10. 3, 4, 9, 10. Carbon 2, 1, 2, 3, 4. Carbon 1, 2, 3, 4. Right? Then oxygen here 1, 2, 3. 1, 2, 3. So the equation is back. All right. So with that, we've been able to see how to tackle questions on alkanols. If you have not seen my video on nomenclature, on introduction to organic chemistry, on hydrocarbons, you can check our YouTube channel. You see the video there. And if you have not subscribed to our channel, what are you waiting for? Please do well to subscribe to our channel and show your friends, and drop a comment if you got value from this class. Thank you, and see you in the next class. Wish you success in your exam.